Hi class, this is Cynthia, and I'm going to be going over questions 13, 14, 15, and 16 with you. So in question 13, we are asked to use our original data set and create a cluster or a stratified sample that contains a total of 10 values. We used the stratified sampling process by separating the data into two groups. The two groups were divided by grouping 1 through 63 and grouping 64 through 126, so each value has an equal chance of being selected. The sample consisted of 5 random values from each group, and we used the calculator to produce those values, and that code was with the random integer. Our values were 3, 6, 16, 23, 59, and then we ran it again for the next 5 values, which were 71, 76, 79, 89, and 126. And there you'll see our groups here and 10 values. For question number 14, we were asked to discuss the proper process from the original data set and create a convenience sample. So we did do the convenience sample method and select 10 values from the data. So we just basically chose 5 values from one group and that were not selected, and then 5 values from another group that were also not selected, and those came from our two groups from creating the stratified sample. The values that we selected were 1, 9, 15, 32, 51, 64, 91, 104, 113, and 117, and you'll see those organized here. For question 15, we had to organize our 3 samples, and you'll see this is our Google link to that document where it has all the organized samples there. We ran a for question 16, we ran a 1 variable summary statistics on StatCrunch, and that was to produce each of the samples which we have listed here. We have the systematic sample that was with 10 values. We found the mean to be 22.51, and here we have the stratified sample with also 10 values and a mean of 30.9. Convenience sample, we have, this was 30.09. Convenience sample, we have 10 values and the mean was 28. And you can see the following information also produced, like the variance, standard deviation, standard error, median, range, the min max, and the Q1 and Q3. Here we were asked to provide a whisker plot for each sample. So we have sample 1 here, and that's going to be our systematic sample, and you can see that whisker plot. And then we have sample 2 here, and that's going to be our stratified sample, and sample 3, which is going to be our convenience sample. And I'll show you those whisker plots. And then for C, we have it's asking us to use a p-value approach and run a ANOVA test to test the claim that at least one of the samples is from a different population mean. So we went ahead and ran that, and that showed us on StatCrunch. We have the population mean for the systematic sample as, again, 22.51. The stratified sample population mean is going to be 30.09. Convenience sample population mean is going to be 28. The claim, again, is at least one of the samples is from a different population mean. Here we have our HO and HA. So we stated that HO, all 3 of the population means are at least equal. And then HA is the claim, again, at least one sample is from a different population mean. So right here we have provided our ANOVA StatCrunch output, and that gives you all 3 of those samples once more, the total number of values, which were the values that we selected or had the calculator random generate. So we have 10 values in each of those samples, and we have all three means listed here, the standard deviation and the standard error. The ANOVA table, it shows us our degrees of freedom for the columns and our p-value, as well as our F statistic too. So our p-value shows you here is 0.5681. That test statistic was used running alpha 0.05 and C 0.995. Our test statistic is F, approximately 0.57751086, and our p-value is again 0.5681. And we can see here that the p-value is greater than alpha. So we concluded with fail to reject HO since the p-value of 0.5681 is greater than 0.05 alpha. There is not sufficient evidence to warrant rejection of the claim that at least one sample is from a different population mean with a c-value equaling 0.95 and an alpha equaling 0.05. That's all we have for you. Thank you.